When you picture the Titanic sinking, you probably imagine a massive, direct crash into an iceberg, like a car hitting a wall. But that's not what happened. In fact, the crew actually managed to turn the ship at the last second. The collision was a long, grinding scrape along the side. And ironically, that maneuver, meant to save the ship, is exactly what sank it. To understand why this happened, we have to look inside the ship. The Titanic was divided into 16 watertight compartments. These were separated by massive steel walls called bulkheads. The idea was simple. If you poke a hole in one room, the water stays in that room. The ship floats. The compartments were sealed using thousands of rivets, and in an emergency, the doors between them could close in seconds. The engines, the boilers, the coal bunkers, all were sectioned off. On paper, it was a fortress. Now, let's look at the enemy. We think of icebergs as soft white snow, but that's just the surface. Below the waterline, icebergs are dense, hard, blue ice. When the Titanic hit, that soft snow crumbled away, but the blue ice hit the hull like a wrecking ball. When the lookout spotted the iceberg, it was too late. The ship was moving at 40 km/h. Stopping was impossible, but the crew did manage to turn the ship. They even reversed the engines. The propellers spun backwards to slow the ship down. It was a heroic effort, but the damage was already done. The iceberg punched holes not in one, not in two, but in 5 compartments. Why did the steel break so easily? The answer is in the rivets. The Titanic used low-quality wrought iron with high sulfur content. In the freezing Atlantic, this metal became brittle. At room temperature, the metal bends. At 6 degrees C, it snaps. This is why the side of the Titanic didn't just dent, it shattered. Thomas Andrews, the ship's designer, calculated that the Titanic could survive with up to 4 flooded compartments. Here's the proof. Now watch what happens when we add a 5th hole. The bulkheads weren't tall enough, water didn't need to go through the walls, it just went over them. One compartment flooded the next, and the next. The ship was doomed. Captain Smith knew the ship was going down within 30 minutes of the collision, but he had a plan. Use the ballast pumps to slow the flooding. It wasn't enough to save the ship, but it bought time. Time to launch lifeboats, time to save souls. The crew kept steam going until the very end, knowing they wouldn't make it out. So, could this happen today? Let's look at a modern ship, the wonder of the seas. First, we don't use rivets anymore. We use welding. When a modern hull gets hit, the steel bends inward but doesn't break. Second, modern ships have double layers. Even if the outer hull is punctured, the inner hull stays dry. And if water does get in, the BGE system pumps it out instantly. Radar, GPS, and satellite monitoring mean we don't get surprised by icebergs anymore. The International Ice Patrol was created because of Titanic. Today we track every iceberg in the North Atlantic. The Titanic is the most famous ship in history, not because it was the biggest disaster, but because it was the most preventable. It's a story of confidence, miscalculation, and the cold reality of physics. Thanks for watching the deep dive. If you want to support videos like this, check out our Patreon. It takes months to research and animate these stories. Your support makes it possible. Take care. See you on the next one.